So last night I finished some of the mechanical mountings for a replacement motor on this old 8,000 pound winch. So I need to disassemble it, take some measurements, make some adjustments, and then reassemble. It's designed to be serviceable. This motor that I'm taking off right now, this came from an old Ego lawnmower. Had some problems, so I was able to salvage some parts from it, including the motor and the battery housing. And it seems to be just a simple brushed DC motor. So it's going to be real easy to get a forward and reverse controller for it, a solenoid. The idea here is that it'll end up being a portable winch, because it'll run on Ego lawnmower tool batteries, and probably also run on Echo 58 volt Echo batteries or 60 volt DeWalt batteries. I don't know if it has the same horsepower as the original motor. This is part of the original motor. That's the commutator. 12 volt DC at about 500 amps maximum. It was supposedly rated for 5.5 horsepower. Couldn't find any specs on the lawnmower motor. Alright, here we go. Time to pull it off from its new mounting screws. I drilled these 4 holes in the flange of the motor so that they would line up with these 4 holes that I also drilled in the housing of the winch. I cut off this piece of the original winch motor housing to use as a spacer. Here's another old winch commutator. That fits right in there. See the spins. The input here, it's about 5/16 inch by maybe 5/8 of an inch. I went with 1/2 inch. This is my adapter, my coupling adapter. So this is a 21/32 diameter shaft with this little keyway notched in there. It's not called a keyway, whatever it's called, that flat spot. This 5/8 by 12 point socket seemed to fit perfectly on that shank. I added a little piece of 1/16 inch thick sheet metal there. That functions as the key. That's just an 832 screw that threads into the tap hole, into the threaded hole on this nubbin. So after careful measurements, I found that the axial spacing is just right. The only thing that doesn't quite fit is this guy here, which I knew that wasn't going to quite fit. So I went ahead and cut and bent this little piece of 1/16 inch thick aluminum sheet metal into a crude spacing ring. There we go. And just push it down like that. I can see through that screw hole that we've got the right gap on this side. There's no gap between the old motor housing and the new motor housing. And through these little witness holes you can see that the spacer ring is still at the correct space. I think this is going to be the final fit, the final installation. Just need to wiggle it a little bit to get those center shafts aligned, and then they're good. There we go. The stars have aligned. And before I tighten up any of the bolts, before I even put nuts on them, you can see that is all actually very solid. That's a good sign. That means all the machining everything's lining up concentrically. These little split washers are for style points mostly. And this is the last one that needs full torque. There we go. And with that, we have a secure mechanical connection. It's time to give it some electricity and see how it sounds, see how she runs. There it goes. So here's the old battery housing. Don't mind this outlet, that's for a different project. Inside of here we have, this is the negative, this is the positive, switch on the positive. I'm a little nervous about this because I don't have the winch actually mounted to anything, so the only thing holding the torque between these two halves are these little bars right here. And they're pretty substantial bars, but they're not in the right places to be carrying torque. I don't have the winch clutch engaged. Right now it's just in free spool mode. Let's see how it runs. Certainly enough torque to get it to jump around. All right, let's try engaging the clutch. There it goes. That is beautiful. Well, that's one successful test. The next thing to do is to get a clamp-on amp meter and see how much current we're carrying on these wires.